Hello student, today we are going to discuss next point of real analysis, limit of a sequence. Okay, limit of a sequence. Limit of a sequence. How to finding limit of sequence? If any sequence is given, then to find their limit. Okay, so here first epsilon n definition. Here epsilon n definition of limit. What is epsilon n definition of limit? Their definition is epsilon n definition of limit is let a sequence Sn where n runs from 1 to infinity is given. Okay, be a sequence. Let Sn be a sequence of real numbers. Sn be a sequence of real numbers. We say that Sn approaches to the limit. Sn approaches to the limit where limit in say limit, suppose that L. Okay, Sn has a means Sn approaches to the limit L as when Sn has a limit L when n approaches to infinity. Okay, n approaches to infinity. That is when value of n is infinity, means limit n tends to infinity of Sn is equal to, then their limit is L. Okay, so epsilon n definition is says that in symbolically that is limit n tends to infinity. Okay, n approaches to infinity, limit n tends to infinity, Sn is equal to L when sequence Sn has limit L if for every epsilon greater than 0, if for every epsilon greater than 0 there exist, okay, here there exist any integer, positive integer n belongs to I, such that mod of Sn minus L, okay, limit Sn is equal to L when if for every epsilon greater than 0 there exists n belongs to I, such that mod Sn minus L is less than epsilon whenever n small n, okay, this n is greater or equal positive integer n. Okay, means here to finding this n such that mod Sn minus L is less than epsilon. Okay, then we say that sequence Sn has a limit L. Okay, this is a definition of epsilon n definition of limit. Okay, so how to finding examples? Suppose that here example using epsilon n definition to finding limit of sequence. Okay, using epsilon n definition, show that the limit of sequence here sequence is given 2n divided by n plus 4 root n. Okay, here given sequence 2n divided by n plus 4 root n, their limit is 2. Okay, means here sequence Sn is given, their limit is L is equal to 2. Here only to show that for epsilon greater than 0, here epsilon you are taking in construction, then you are to find n, this number is we have to find it, then this sequence is satisfying this condition, Sn minus L is less than epsilon, then limit n tends to infinity, Sn is equal to L. Okay, so solution of this example. Okay, let Sn is equal to n runs from 1 to infinity, here also is equal to Sn is equal to 2n divided by n plus 4 root n. Okay, where n runs from and that is or that is Sn is equal to 2n divided by n plus 4 root n, and we have to given that or also given that we have to show that limit of given sequence is 2. Okay, we have to show that Sn sequence Sn has limit 2. Okay, their limit is 2, that is to show limit n tends to infinity, Sn is equal to 2. Okay, how to show? By using epsilon n definition. What is epsilon n definition? By using epsilon n definition. Here epsilon n definition says that when given sequence Sn has limit L, if for every epsilon greater than 0 there exists here at least one any integer here exists in such, n belongs to I such that Sn minus S is less than epsilon whenever n greater or equal n. Okay, so by using epsilon n definition, for all here for all epsilon greater than 0, by using epsilon definition for every epsilon greater than 0. Okay, so for all epsilon greater than 0 we have to find positive integer. Okay, we have to find positive integer n, this is belongs to I such that mod Sn minus L is less than epsilon where n is greater or equal n. Okay, so we have to find here this integer n such that mod Sn minus L is less than epsilon for all n greater or equal n. Okay, so consider this modulus, consider mod Sn minus L. Okay, consider mod Sn minus L, putting value of Sn, their value is 2n and here L is 2. We have to show limit L is 2. Okay, so L is putting their value L and Sn is equal to n plus 4 root n minus value of L is 2. Okay, value of Sn minus L is equal to 2n divided by n plus 4 root n minus 2. Then here so taking denominator is same, we get so here taking here we have to take denominator same, we get okay mod Sn minus L is equal to Sn is given that 2n divided by n plus 4 root n minus 2. So taking denominator is same, n plus 4 root n. Okay, then multiply 2n minus 2 into n is minus 2n plus 8 root n. Okay, and their value is 2 2n to n get 0, then their value is mod 8 root n divided by n plus 4 root n. Okay, Sn minus L, their value is 8 root n divided by n plus 4 root n. Okay, so here 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 n plus 4 root n plus 4 root n is strictly greater than n, because here n is same, we are only adding this term. If we adding in n this term n plus 4 root n, their value is always greater than n. Okay, so then their reciprocal is 1 upon m plus 4 root n is always strictly less than 1 by n. Okay, then we have to multiply this term 8 root n, so both sides we get, since a plus b greater than a, and here 1 upon a plus b, or here if a greater than the b, then 1 upon a is less than 1 upon b, this using this result. So here multiply 8 root n in both sides, we get 8 root n divided by n plus 4 root n is strictly less than 8 root n divided by n. Okay, since 1 upon a less than 1 upon b, which implies that c upon a is also strictly less than c upon b. Okay, using this result we have to find in here, then which imply that 8 root n divided by n plus 4 root n is strictly less than 8 divided by root n, because n is value of n is root n into root n, where one root get cancelled, remaining only 8 upon root n. Okay, so that is mod of Sn minus L. Value of mod Sn minus L is mod of Sn minus L value is mod of 8 root n divided by n plus 4 root n, but 8 root n divided by n plus 4 root n is strictly less than 8 by root n. Okay, so which is less than mod of 8 root n. Okay, so take epsilon is equal to 8 upon root n, we get means mod Sn minus L is strictly less than epsilon. Okay, so we have to finding integer n, so epsilon is equal to taking 8 divided by root n, which implies that value of root n is equal to 8 upon epsilon. So squaring on both sides, we get n is equal to 8 square is 64, and there epsilon square. Okay, this is a positive value. Okay, therefore n is equal to 64 divided by epsilon square. Here, since definition says that since n is greater or equal n, which implies that value of n is 64 divided by epsilon square is greater or equal n. Therefore Sn minus 2 is limit Sn minus 2 is less than epsilon whenever n means 64, whenever their limit is 2, whenever 64 divided by epsilon square is strictly is greater or equal n, and therefore by definition of limit of sequence, for all epsilon greater than 0, there exist n belongs to I such that mod Sn minus 2 is less than epsilon for all 64 divided by epsilon square is greater or equal n. Okay, and therefore this n is here exist, so this is 64 divided by epsilon square, such that we satisfy this condition. Okay, we satisfy Sn minus 2 is less than epsilon for all 64 divided by epsilon square is greater or equal n, and therefore by definition of epsilon in definition Sn has a limit 2. Okay, therefore therefore uh, limit limit n tends to infinity Sn is equal to 2, that is limit n tends to infinity 2n divided by 4 n plus 4 root n plus 4 root n is equal to 2. Okay, so how to solving this example? Here only to consider that here find epsilon and n for every epsilon greater than 0. For every epsilon greater than 0, there exists this integer n belongs to I such that mod Sn minus L is less than epsilon whenever n greater or equal to n. Then in sequence Sn has a limit is this L. Okay, so here considering this here only to considering Sn minus L, then we get a solving rearranging this equation. We get mod Sn minus L has a value is 8 root n divided by n plus 4 root n. So here only clearly n plus 4 root n is always greater than n, because here n plus 4 root n is this term is adding in n, then their value is always greater than n. So then their reciprocal 1 upon n plus 4 root n, their value is always less than 1 upon n. Okay, so here only multiply 8 root n divided by then their value is always as it is. Okay, so here we have to finding, then 8 root n divided by n means 8 divided by root n, because n has value is root n into root n. So 1 root get cancelled, remaining only 8 upon root n. So therefore this value is a value of mod Sn minus L, then their value is, and this value is less than n, which implies that mod Sn minus L is less than 8 upon root n. So here condition is mod Sn minus L is less than epsilon. Here epsilon is taking epsilon is equal to 8 upon root n, then which satisfies Sn minus L is less than epsilon. Okay, so here taking epsilon is equal to 8 upon root n, which implies that, so arranging we have to finding this n is always greater or equal n. Okay, so n we have to find taking epsilon is equal to 8 upon root n, then root n value is, so rearranging this equation and squaring, so n is equal to 64 divided by epsilon square. Okay, so n is equal to 64 divided by epsilon square, which implies that here condition is n is greater or equal n. Okay, and n is 64 divided by epsilon square, which implies that taking n is equal to 64 which is n is equal to 64 divided by epsilon square is always greater or equal n. So here 64 divided by epsilon square is always greater or equal n. So n is exist here. Okay, n is exist, which implies that mod Sn minus 2 is less than epsilon whenever this 64 divided by epsilon square is greater or equal n. Okay, greater or equal n, which implies that by definition of limit of sequence or epsilon n definition, so mod Sn minus here for all epsilon greater than 0, there exists n belongs to I such that Sn minus 2 is less than epsilon whenever 64 divided by epsilon square is greater or equal n. And so sequence Sn is satisfies this all condition, therefore sequence Sn has a limit is 2. Okay, so this is one example. Then